Okay, so now just looking at the fundamental theorem of calculus, theorem 5.1, it says that if f is non-negative and continuous on a closed interval from a to b, then the integral from a to b of f of x dx is equal to big F of b minus big F of a, where f is any function where the derivative f prime of x is equal to little f of x for all x and b. And what this is really saying is that something I've already been saying is that derivatives and the integral, or their integrals, are inverses. They're inverse functions of each other in a sense. And here it's saying that remember that they weren't inverses per se if you took indefinite integrals because you're off by a constant. But if you actually give the bounds a and b, then we have a true inverse process. So that taking the integral and then taking the derivative gives you back what you started with in a sense. So let's look at example 5.15. It says we want to find the definite integral from 0 to 2 of e to the 3x dx. And so all that's saying is we want to find the area from 0 to 2 of this curve that's going to start up. It's going to go through 0, 1. It's going to go through 1 comma e and 2 comma e squared. You know, it's growing like an exponential. Actually, no, it's going to go through 1 comma e cubed, and it's going to go through 2 comma e to the 6th. So it's growing really fast. And we want to figure out what is the exact area of this red shaded region. So that's A. And so this area is going to be equal to the integral from 0 to 2 of e to the 3x dx. And remember that to take that integral, you should do a u substitution. So u is equal to 3x. And in that case, du is equal to 3 dx, or dx is equal to du over 3. And so you can do a u substitution, and when you do that, I always write x equals 0, then x equals 2 there if I do a u substitution to remind me to plug in x. So this is going to be e to the u, and then dx is equal to du over 3. So that is 1/3 e to the u, and I need to plug in x equals 0 and x equals 2 into that, and since I haven't plugged back in for x yet, I can't do that. So I should write this as 1/3 e to the 3x, and then plug in x equals 0 and x equals 2. Okay, and now I get 1/3 e to the 3 times something minus 1/3 times e to the 3 times something. And in the first copy I put in 2 because that's my upper bound, and then in the second copy I put in 0 because that's my lower bound, and I'm getting 1/3 e to the 6th minus 1/3 e to the 0, so that's just minus 1/3. Okay, so what we found is that our area A is actually equal to 1/3 e to the 6th minus 1/3. That's the exact area of that red bounded region.